Okay, good afternoon, everybody. We were seeing the unit 3 regarding the various types of fermentations in the last class. Various types of fermentation, batch, continuous, or multiple batch we have seen. So today we will see what is alcohol production. So alcohol production, so through fermentation only we can produce alcohol. So fermentation is the process in which a substance breaks down into a simpler substance. Okay, we already defined this in the earlier classes. Fermentation is the process in which a substance breaks down into a simpler substance through a more complex substance like sugars, glucose, sucrose, etc. Then microorganisms like yeast, both yeast and bacteria will play a major role in the fermentation process. So examples of the fermentation products are sucrose, what we call this, beer, wine, bread, yogurt, and other food type of products are there. Curd is also one type of fermentation product. So examples of fermentation products are nothing but beer, wine, bread, yogurt, curd, etc. Cheese is also a fermentation product. So what is the role of this yeast and bacteria, which play an important role in the fermentation? So many types of yeast and bacteria will play a major role in the fermentation process of ethanol to produce ethanol from the sugar sources like sucrose or glucose. So what are the raw materials involved? We have to see. So first we will see what are the raw materials involved. So as soon as the fermentation process, how the fermentation process differs from the other process. The fermentation process retains most of the energy of the sugar in the form of ethanol, in the ethanol production. In the fermentation process, overall, the most of the energy which the sugar processes will be stored in the ethanol. So this is ethanol production. Then many types of raw materials has been used for ethanol production, like molasses is the best sources to produce ethanol throughout every industry. But many people are using sugar beets, potatoes, corn, and sugar cane. So ammonium, nitrogen sources like ammonium sulfate and ammonium phosphate. Some of the yeast and bacteria, as we have already discussed, they required some nitrogen and carbon sources, like here the yeast which are used here, the bacteria which are used here in the ethanol production required a nitrogen source. So in order to supplement this for a nitrogen source, we are using ammonium sulfate and ammonium phosphate here. So ethanol can be produced from other chemical processes also, but attention has been paid to the production of ethanol or for chemical and fuel purposes by the microbial fermentation process. So in the fermentation process, so this is the organic source, microbial production of one of the organic feedstocks from the plant substances. So molasses is used. So here the molasses is used as a basic raw material, whereas sugar beets, potatoes, corn, and sugarcane can also be used to produce the ethanol. Then what are the bacteria we have to use? So bacteria and yeast, both the yeast and bacteria will play a major role in production of ethanol. The yeast like Saccharomyces cerevisiae, S. urm, S. Carlsbergensis, Candia brassica, C. utilis, Cluveromyces fragilis, K. lactis. These are the yeast sources, bacterial names, the biotechnological names of the yeast, and the bacteria like Zymomonas mobilis. These bacteria have been employed for the production of ethanol in many industries. Then there are many types of fermentation processes which we have seen in the earlier classes, like the batch fermentation process, continuous fermentation process, then dual or multiple fermentation processes. All these type of processes can also be used, but large scale ethanol production can be produced using the continuous process only. So continuous processes which will give a yield around 47 percentage from the sugar source is popularly used in the industries. Then as you can see from this reaction, the sucrose C12H24O11 can be converted to the bacterial or a yeast action, the microbial action, to the ethanol and release of four molecules of CO2, carbon dioxide. And at the same time, glucose can also be used as a raw material in order to obtain ethanol with the liberation of two molecules of carbon dioxide. Now, all these reactions, the bacteria or the yeast, whatever the particular industry is employing, will play a major role in converting the sugar sources like glucose or sucrose to the ethanol. So, large part of the whatever the energy that sugar contains will be retained in the ethanol. So, fermentation processes are obviously preferred for the benefit of this one. So, process, how this process will take place, like raw materials like sugar cane or sugar beet or nowadays corn or using, or potatoes or using, whatever the glucose sources or sucrose sources are there, they are using that sources to manufacture the alcohols, industrial alcohols. Then first we will see in the molasses section. So sugar cane, from the sugar cane or sugar beets we can obtain a molasses. Okay, molasses is the raw material which is present in the sugar. So molasses is used as a feedstock for ethanol production. Then, first sugar cane or sugar beet, okay, which is just reduced in a size using a chipping mill. In the chipping mill can be just sent to the extraction of sugar, where sugar cane juice will be extracted. Then that particular sugarcane juice, whatever the molasses left after obtaining this juice, will be sent to the fermentation tank. Or otherwise, we can say the primary feedstocks like corn or the frigate sources, after grinding or after cutting, so it will be sent to the mashing section. Mashing section is nothing but a process in which enzymes and that particular raw material will be mixed thoroughly. So that is called a mashing. Mashing and cooking. After cooking, that will be sent to a fermentation column. Here the bacteria or the yeast, whatever there, it will play a major role. So bacteria we already described in the earlier slide. So bacteria yeast like Saccharomyces cerevisiae, S. uvarum, S. carbelsinensis, Candida brassica, C. utilities like and bacteria like Xymomonas mobilicis can also be employed in the ethanol production. Then ethanol is produced by the largely by the continuous process, because it has a larger yield compared to other process, and hence large fermentations are used for continuous manufacture of ethanol. Then the sugar sources and glucose sources, all the sources which are used as described in the reaction. Then all the sources, this is the raw material source. After mashing and converting them in a cooked form, all this cooked form will be sent to the fermenter. Then how to mash this one? The crude molasses, whatever is there, obtained after the extracting the sugarcane juice. So that molasses is used as mash and generally requires only to be diluted and pH to be adjusted around 4.5. So the pH of this, whatever the raw materials are there, they needs to be diluted and pH needs to be adjusted around 4.5, so that it remains in the acidic, because this pH is favorable to many yeast and unfavorable to many bacteria. So yeast plays a major role in production of ethanol. So this pH 4.5 pH is very much important, so that which is favorable for the yeast. So bacteria cannot remain at that pH. Sources of that what we call the nitrogen sources like ammonium nitrate and ammonium phosphate and ammonium sulfate can be used as a nitrogen sources for the yeast. Then the final solution is whatever the after the fermentation, the final solution will be obtained as a rich nutrient carbohydrate, which is composed of a carbohydrate culture medium of mash. So mashing is nothing but, as I already said, it is a making of a soluble raw material with the enzyme adjuncts is called a mashing. Then after mashing, in the fermentation, final product will be obtained as a rich nutrient carbohydrate source. That carbohydrate source will be the yeast will be acted upon that carbohydrate source in order to convert them into ethanol. So in the enzymatic hydrolysis, whatever water using the water, we are diluting our raw materials. So temperature plays a major role in obtaining the ethanol, successful ethanol production. So temperature and pH. pH we already said. So 4.5 is very much favorable for the yeast, and they are not favorable for the bacteria. Then the temperature will be kept around 35 degrees centigrade. Then after the fermentation process, the final product obtained is called a pure culture or inoculum. As described in the earlier classes, the inoculum is nothing but production of bacteria, multiplication of that yeast component, so that will be consumed by that consumes whatever the raw materials we are supplying, like corn, or whether it may be sugar cane, whether it may be molasses, whether it may be a potato. So that inoculum, the pure culture inoculation, whatever is there, that yeast will be multiplied. That multiplication of yeast will consume that raw materials like corn or sugar cane. Then it will be converted, that sugar sources will be converted to the rich carbohydrate sources, nutrient sources. And after the final product is obtained from the fermentation, so overall this fermentation process can be carried out around 12 hours to more than 24 hours. Then after fermentation, whatever the biomass obtained will be separated from the supernatant. Supernatant is nothing but a top layer, which is nothing but a alcohol layer, and the bottom is the solid layer, which is called which is a good source, single protein source for the animal feed. So that single source of animal feed, which is called a biomass, that biomass can be separated from the supernatant. That biomass will be sent to the animal one. Then after that, supernatant can be purified. The supernatant here given as a beer. This can be purified. So beer will contains around 14% alcohol. So it is very dilute percentage of alcohol will be retained in the beer form. So that is called as a beer or a supernatant in the fermentation process. Whatever the layer are there is just sent to the. So this primary distillation column is just a simple distillation column in which up to 95 percentage of ethanol can be separated. Because at 95 percentage ethanol, so remaining will be just 5 percentage with water. It will form a azeotrope. In the mass transfer class, we have defined the ethanol and water will form a azeotrope. At this composition, 95 percentage strength of ethanol, ethanol will form a azeotrope with water. So it cannot be separated with a normal distillation or a simple distillation. So we have to use a secondary distillation, also called as azeotropic distillation. So in the azeotropic distillation, what will happen? The benzene, a third component, a entrainer we will call. The entrainer benzene will be added in order to obtain a pure ethanol. So that it will just uh, whatever the water and azeotrope water is forming azeotrope ethanol, that azeotrope will be broken down using the third component column, then a pure ethanol can be obtained. So this ethanol is ready for the packaging. So this is called an absolute ethanol. So 100% ethanol. So first I will revise once again. So whatever the raw materials are there, the raw materials like sugarcane or sugarcane beets or molasses, in the precious manner, molasses we can call corn, potatoes, everything is there. Whatever whatever the raw materials we are giving, it will undergo a primary grinding or cutting, okay, primary size reduction mechanism. After reducing the size, whatever the sugarcane juice, everything will be extracted down. The molasses which is obtained during the sugar preparation can be sent to the fermentation process, or otherwise when we use a corn, we will use a grinding in order to obtain a fine powder. Then mashing and cooking will be takes place. So mashing and cooking is nothing but mixing of an enzyme along with the raw material thoroughly. Then after mashing, it will be sent to the fermentation together. Whatever the other sugar sources are there, it will be sent to the fermenter. Here the yeast plays a major role. So in order to survive the fermentation process, the yeast to be having a pH of 4.5, because the this 4.5 pH is very much favorable for the yeast, and many bacteria will die, will be inactive at the pH 4.7, and the temperature can be kept around 35 degrees centigrade. Usually this is carried out around 12 to 48 hours, the fermentation process. After the fermentation process, whatever the biomass obtained, whatever the solution obtained, so the solution will contain a biomass in the bottom layer, which is the solid or a single protein source, and the top is called a supernatant. The top product which is there will be separated out. That top product, which is called a supernatant, will contain a very dilute amount of alcohol. That dilute amount of alcohol will be just concentrated using a successive distillation column. So first beer is nothing but a very dilute which contains very dilute amount of alcohol, around 11 to 14 percentage alcohol percentage will be there. Then it will be sent to the primary distillation column. Here the primary distillation column is a simple distillation column. In the simple distillation column, just by application of heat, we can separate the ethanol up to 95 percentage concentration only. Further, if you want absolute alcohol, 100% alcohol, we have to separate using the azeotropic distillation column, because ethanol forms azeotrope with water at 95 percentage strength of ethanol. Then it will be sent to the 95 percentage ethanol will be sent to the secondary distillation column, which is called a azeotropic distillation column. In the azeotropic distillation column, a third component called as a entrainer, which is here benzene is used so that it can just break down the azeotrope between water and ethanol, so that we can obtain a pure ethanol as our purified product, absolute alcohol. So this will be ready for the commercialization. So I hope you understood. Do you have any doubts?
No, sir. Continue, sir.
Okay. Um, I will stop this one. Just I want to take a feedback whether you are understanding or I am going very fast or something. Already third unit is about to complete. Only one topic is left. First we will discuss how the biogas is important for the India. So the Indian scenario, we will see how it is important for the India. Then what are the feedstock sources, and one flow sheet is there, how that biogas will be produced. We will see that one. So this is the last topic in our third unit. So I just want to know whether you require anything extra, anything additional apart from this, or shall I continue like this? If you are liking like this, I will continue, or otherwise I will slow down somewhat. So mass transfer operations only 1.5 unit completed, but this is about 3 units we completed. Just give me a feedback. Okay, not only CR, anybody can speak. Yes, yes.
Like
Ravi.
CT1 in exam, they will ask mainly, they will focus mainly on float sheets and all, no, sir.
Yes, 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 yes.
We could spend some extra time on float sheets, no, sir.
Yes, definitely we can spend. Yeah, but in this one, in especially in the chapter third unit, only two flow sheets are there. One is the ethanol production, and next one is this biodiesel, biogas production. So these flow sheets are there only. So apart from this, all are these flow sheets. I just give it. I just
Microbiology.
give no. These flow sheets I just given for the representation. So they are never asked about this fermentations. You are saying something, micro?
No, apart from this float sheet, everything is related to biology in this chapter.
Yeah, in this chapter, everything. I don't know why they kept in between that one. If you
Yes,
see, the
yes,
next 2 units are completely our chemical technology.
yes, sir.
Framed in this
Because
syllabus.
in chemical technology one, we only focused on float sheets.
Yeah, that's the inorganic chemistry, I guess. Inorganic chemical technology, I guess.
No,
Sulfuric acid production, something. Am I right?
sulfuric acid,
Yeah,
ammonia,
yeah. What happened in the last batch, your senior batch? In their case, they never asked about flow sheet. If you just verify that earlier paper, they asked about only theory.
CT1, sir.
No. CT2 for
Mhm.
the earlier batch,
Yes, sir.
2017 batch, I guess that. For the
Same thing happened.
2017 batch, yeah.
Same thing
I
happened
just,
for CT1 also, sir. For them,
yeah. Because
CT1 also they asked only theoretical questions. For us, they asked again flow sheets, full flow
okay.
sheets.
Yeah. That's why I'm spending on the flow sheet also, and the same time theory also. Because in the last class also I have done same thing, but they neglected. They just verified the earlier papers, and they neglected the theory part completely. So that
Yes.
was the case. So in the flow sheet means I have to just revise the earlier chapters, or shall I continue the next one?
Continue next two chapters, focusing mainly on flow sheets, sir.
Okay, yeah, I will focus mainly on flow sheet. Okay, then next chapter is the pulp and paper industry. So in the pulp and paper industry, what happens? I just covered what is the history of paper, how history what is history saying about paper. So if you want that one, or shall I just go to directly flow sheet so
Tell
that
sir,
I.
tell about history also, sir.
Yeah, okay. Yeah, I will say about that one, and just and at the end of that unit, I will say what are the slides which are very important for your examination point of view. Is it okay with that?
No, sir, you can continue just as you are doing now, but spend
Hmm.
some more time on flow sheet, sir. That's it. Because we
Okay.
are going very fastly now, sir.
Yeah, yeah, yeah. Okay.
If we can utilize that time on flow sheets, that would be.
Okay. Yeah. Okay. Thank you. Yeah, this ethanol production. Do I want to revise this one or just go to the next one?
Tell us about the changes that occur due to pressure and temperature. Why we have chosen these temperature and pressures as optimum.
Optimum temperature. Okay, it is more detailed process. Okay, I will just study and tell you. So
Because
for
in CT1 we used to study
hmm,
why we have chosen this pressure, what happens if
yeah,
we
yeah.
increase the pressure, decrease the pressure. We used to study detailedly all the flow sheets.
Okay, okay. Yeah, in the earlier also nuclear production or the second unit, whatever there, we are studying about engineering problems and everything. In the
Yes,
engineering
sir.
problems, if you see what are the materialistic problems, what are pressure and temperature effects, we have studied. But this unit I can't found in your prescribed textbook. So I have to take these sources from various papers.
Yes, sir.
So I can't verify the genuine source, how they are just increased. This flow sheet I just found from some other source, internet source. So
Yes.
it's not a complete flow sheet. Then one or two times they are asking this flow sheet. Okay, if you required, I will just concentrate more on this one. So this flow sheet I will try to explain once again. Okay, in the next class, I will try to explain this flow sheet in detail. You are asking about temperature and pressure. Maybe because of bacteria will die above 35 degrees centigrades, I guess it will maintain at 35 degrees centigrades. Because incomplete conversion will be observed below 48, need not be a 48 hours. It will be around 12 to 48 hours. Because in the during the diploma studies, we just synthesis the alcohol from the molasses. Okay, when we during our experimentation we observe in 24 hours it is supposed to form the product, fermentation product, but we observe that it is not at all forming, maybe because of quality of molasses, I don't know. Because supplying molasses, taking molasses from industry is very very difficult because they don't supply. So because of that, maybe we encountered some problem. So we can say here 48 hours is not a optimum one. We can say 12 to 48 hours depends on many conditions, whatever the physical parameters, surrounding temperature, everything we are accurately maintaining or not. And the temperature maybe this 35 degrees centigrade is regarding this bacteria, whatever the enzymes will be there, maybe because of that 35 degrees centigrade will be a ideal. So I will further study this one and let you know regarding this one. Okay, if anybody wants to give me a feedback apart from CR and ACR, only I can able to have a feedback from ACR and CR only. So it is very confusing for me whether I am going in the right direction or the wrong direction. Please just guide me. Vamsadhara?
Yeah, I sir.
Yeah, yeah. Do you have any feedback? You want anything extra?
No, nothing, sir. Everything is alright.
Okay. Isaac, I can ask since they are very active. Isaac, yes, Isaac.
No, sir. The whichever I want to tell, Seattle, sir.
Okay, okay, yeah, okay,
We are focused on like process and more on that, sir. We like chemical reactions and how
yeah.
could we increase yield. So we focused on something like particular things in reactions and that, sir. So we want to learn about it also.
Okay, okay, reactions. Okay, there is no big reactions in this one.
Uh,
So,
as a part of
We
CE,
will
we have we don't have much reaction in this.
yes, yes,
forward reaction and reversible reaction if in a bauxite reactor when we are doing synthesis of ammonia and everything, if we
mm,
increase the pressure it will take place a reversible reaction, so we have chosen
yeah,
this
yeah,
pressure.
yes, yes.
So that like that we used to study detailedly sir, everything.
Yeah, yeah, that's the engineering problem we have seen in 1 and 2 units, that's soap production and nuclear production. So in this chapter, there is no such a criteria like engineering problems or something. So unit one and unit two, unit three is completely a chemical technology, and unit three is a microbiology. In this one, there is no engineering problems. So that enzymatic and everything, so I will just search for this one. And next fifth unit is also regarding food technology, and corrosion. Okay, maybe in this also there is no big flow sheets. Okay, I will try this one. Okay, in this one I don't remember, I don't know. They will have a temperature and pressure conditions accurately. What will happen? We have to search for the papers. So I can't find your prescribed book also, textbook also. Okay, then same thing I will try to incorporate in the next class, from the next class onwards. Okay, Pavani,
Sir,
yes, you want anything more? Give me a feedback.
nothing, sir.
Okay, is it true?
Expecting. Really, sir.
Okay, yeah, number three, Anusha, I guess. Yeah,
Sir,
yeah. Do you have anything to add?
no, sir.
Yeah, okay. One, I think Ananya it is. Yeah, one, number one.
Yes, sir.
Yeah, do you have anything to add?
No, sir.
Okay, yeah. Okay, then. Okay, we will continue. If you have anything else, just tell me in between, or otherwise, I would have wind up all the units. Then I come to know that you didn't understand anything. That will be very painful for me. So, okay, before that, you just say to me what do you want extra from me. Okay, then next we will see what is a biogas. Okay, biogas is nothing but a natural gas whose main composition is a methane. Okay, whatever the animals, if you can observe during our when we are walking around the roads, then you can observe some of the animals are just lying behind in a dead condition. So whatever the degradation process is taking place in the animals or some plants, the gas which is released is largely a natural gas which is called a methane. So biogas is obviously composed of a methane, and to some extent carbon dioxide will be there, and to a small amounts of hydrogen sulfide and moistures and siloxanes will be there. So this is the overall composition of the biogas. So biogas is a mixture of gases produced by the breakdown of organic matter in the presence, in the absence of alcohol. Okay, whatever the organic compounds are there, they are just break down into the degraded, they are about to degrade. So during this degradation process, whatever the gases formed is called the biogas. So using this benefit of this natural degradation process, so we can use various sources like plant source, whether it may be a plant source or whether it may be a animal source. The plant-based biomass can be obtained from plants like agricultural residues. We can use agricultural residues like apple pomace and deteriorated or dumped wheat grains, municipal waste, plant material, sewage, green waste, or food waste. All these sources can be used in order to just give to the digester column, the digester section. In that digester section, the methanogenic bacteria, they will play a major role in that one, in breaking down this organic matter. Then while animal based biomass include cow dung, so gobar we can say, so biomass is usually referred as a gobar gas. So the cow dung can be used as an animal source for the biomass production. So these are the feedstocks which can be used to produce the biogas. Then stages in biogas production. So what are the stages in the biogas production? Okay, we will see in detail in the next class regarding this one. So okay, we will go to the little bit to the earlier units. Yeah, okay, Ravi.
Yes, sir.
In the unit 2, do you have anything like you are asking about some reactions or something? Okay, here if you see in the major engineering problems we used to discuss as far as chemical technology main principles are involved. So all that we are the problems which are encountered like temperature, what will happen and everything we try to discuss here. So here if you see the thermodynamic and kinetics problems, I already said. So in the kinetic problem, the reactants will obviously go decreasing the carbon number. Then the products will increase in the carbon number. That's the verification for the product formation. Then from these difference in the energies, we can say that delta H is negative delta H. So negative delta H indicates is the exothermic, slightly exothermic reactions. So these reactions, so this is the reaction which is exothermic. So we need to maintain a low temperature. So we need to maintain some cooling. We have to give some cooling. So then this is a kinetic problem. So kinetic problem, I already told you these are the 8 stages are there. So if you see in the catalyst process, whatever the bulk solutions are there, whatever the bulk solutions are there, that from the bulk solution the required amount, the required molecule needs to be come from the bulk solution. Like in the first one, if you see the hydrogen is there, so hydrogen and oil. So in the hydrogenation and oil, the two raw materials are, one is hydrogen, sorry I forget this one. Okay, yeah. Okay, the two raw materials are there. So two raw materials. First in C, these two will be in a mixture form. So first from the, this can be considered as a bulk. So from the bulk to the solution on the top of the catalyst surface, it has to come. So it will undergo some what we call the diffusion process. So this is the top of the catalyst surface for the H2, and this is the top of the catalyst surface. Top of the catalyst surface means external catalyst surface. Okay, so that molecule needs to be come on the external catalyst surface. So this molecule, thus whatever H2 is there, it will form a solution with oil. So this first one is the solution with oil, and then this solution with oil from the solution to H2 needs to be come to the external surface of the catalyst. From the external surface of the catalyst, it has to go to the inside of the catalyst. So that is called a chemisorption. Okay, chemisorption inside of the catalyst. So after going inside, it has to attach on the interior surface of the catalyst. Then the diffusion, after diffusion, so this molecule needs to be attached on the inside surface of the catalyst. So that inside surface of the catalyst, and this is also inside surface of the catalyst, these two molecules will interact with each other and they will form this surface reaction on the catalyst. So then after forming, after surface reaction, the whatever the products are there, these products will be formed. These products will once again has to come out from the internal surface to the external surface. So that is called a desorption. Internal surface to the external surface is called a desorption, because adsorption is the phenomena which is observed in solids. Because here our catalyst is in a solid form, so it needs to be dissolved from internal surface to external surface. And the next step is diffusion of fat, whatever the products is formed. So diffusion, external surface to bulk of the solution it needs to go. Okay, like this the kinetic problem will be encountered. So mechanism in the manufacture of whatever the product we are manufacturing, in the manufacturing, what plays a major role is in the chemical reaction engineering, what is the governing step, what is the rate defining step we need to confirm first. uh, Depending on that only we will just able to design whatever our reactors, how to design that reactor, how much a desired product ratio, how much the selectivity will be there. Everything will be dependent on what is the rate controlling step. If you know what is the rate controlling step, then it is easy to design any type of reactor. So that is called a design problem. Because of design problem only, this thermodynamic and kinetic problems we have to study more. In the thermodynamic problem, because this of exothermic reaction, so we have to supply some external jacket so that inside some cooling water will be circulated, that reaction temperature will be lowered to some extent. So because of this only we are studying the thermodynamic. It is also defining what type of reactor we have to manufacture, whether it is a jacketed reactor or whether it may be a simple reactor. So from this thermodynamic consideration, we come to know there is no criteria for selection of a simple reactor for the hydrogenation process. We need to define, we need to design only the jacketed reactors. So we come to know that conclusion from this thermodynamic engineering problem. Then from the kinetic problems, using first we will just what we will do, it's majorly a research problem. Okay, first during this interaction with the catalyst, we will just assume diffusion to be controlling. So how this rate controlling step is evaluated, you come to know in the mass transfer 2. In the mass transfer 2, during the adsorption chapter, uh, uh, you might know how to derive these equations, the rate controlling step derivation. First, out of these 8 steps, you have to assume one of the step is a rate controlling step. So rate controlling step, as you might have learned in the CPP course, rate controlling step is that one which will take place very slowly. Okay, that is a rate defining step. So we have to, out of these 8 steps, we have to first assume which is a rate controlling step. After that only we can just move on to derive the equation. Then after derivation, whatever the data we are observing, the reduction of concentration and formation of products together with a time, so that data is fitted to that particular rate equation or not, then we have to verify that one. Then we come to know this is a kinetic problem. Here this is a kinetic shifting kinetic problem, this one. If you go deep inside this, the research of this hydrogenation process, I already said you this one. So during the initial steps around 100 degrees centigrade, the rate control, here see kinetic factors. Since hydrogenation gas liquid reaction, 8 kinetic resistance exists in the vicinity of 100 degrees centigrade. Around 100 degrees centigrade, what is the rate controlling step? The surface reaction and adsorption controls the rate. This surface reaction and whatever the adsorption are there, this chemisorption and this chemisorption, these two and this one. So 5, 3 and 6 will be a controlling step, rate controlling steps. So from this rate controlling step only we will derive the equation so that it will can fit in our experimental data. Then only we can confirm how they obtain this conclusion at the 100 degrees centigrade. These 3 are the rate controlling step, because they assumed initially that maybe this one is a rate controlling step. A lot of research has been involved in confirming what you are learning now. It is simple words like in the vicinity of 100 degrees centigrade, surface reaction and adsorption controls the rate. So whatever you are learning in a simple one word definition, one sentence definition, is because of a lot of research, many types of research papers. Then they come to know that in the 100 degrees centigrade, the rate controlling step is shifting. Okay, rate controlling steps are the only these 3 only. We need not to go for this one. So obviously when we define the rate controlling step, then the rest of the other steps will be automatically happen. So in the conclusion, they just given a conclusion as 100 degrees centigrade surface. So these 3 steps are the rate controlling steps. How to confirm this one? It's a lot of years research is involved. then the rates are increased by increasing hydrogen pressure. Whatever the rates are there, hydrogen, since hydrogen is our primary reactant in hydrogenation process, the rate, the high pressure is nothing but a raw material. Usually for the gases, we will measure the mole fractions or the mole fractions of the composition in terms of pressure. So high pressure, whatever the composition we will supply hydrogen, the large amount of hydrogen will be beneficial for the hydrogenation process. In other words, this statement can be written as a large amount of hydrogen. A large amount of hydrogen is very much beneficial for the hydrogenation process. So maximum pressure is this one, 7 atmospheric gauge. Because after this one, we have to take a design consideration of the reactors also. Because reactors are designed according to their design pressures. After that design pressure, the reactor will burst. So we cannot go beyond the design pressure. Whatever the vendor is supplying, the reactor, particular vendor is supplying that reactor, he will suggest the specifications will be indicated. So this particular equipment will be used up to this maximum pressure only. After that, we have to increase that design limit, or otherwise we have to conduct that particular experiment or the particular production below that limit only. So then 180 degrees centigrade. In the 180 degrees centigrade, mass transfer for solution of H2 and diffusion to and from the catalyst or rate controlling step. So solution of H2. So at 180 degrees centigrade, 1, and diffusion 1, 2, 3, 1, 1, 2, 5, 1, 2, okay, 1, 2, 1, 2, 4, 78. 12478 will be a rate controlling step in the vicinity of 180 degrees centigrade. So how can they confirm that at 180 degrees centigrade these are only the 1, 2, 4, 6, 1, 2, 4, 7, 8, these are the rate controlling steps? This is also a research problem. They have to define that one. They have to conduct numerous number of experiments, then only they can define, okay, that this is going to be a rate controlling step, so we can incorporate in our design. When so hydrogenation temperature will vary between 100 to 180 degrees centigrade, or to 200 degrees centigrade, nearly 200 degrees centigrade it will vary, for example. So how can we design the reactors? By incorporating all these factors we only design. For example, if some researcher conducted an experiment and he confirmed that below the 100 degrees centigrade only the surface reaction is rate controlling step, then what will happen? So maximum pressure conditions we will neglect, and the other rate controlling steps we will neglect. So we will give a large pressure of H2, so that obviously that reactor will be blasted. So that will happen. So we have to study all these engineering problems. Then handling of H2. So I already told you H2 is a wide explosive, which is a wide explosive limit. So concentration limit will be 4.1 to 74.2. So that limit, when it reach, it will be blasted. And the equipments, in order to ensure that hydrogen doesn't react with other type of any gases, oxygen is not present inside that one, we have to purge that one. Purging is nothing but by just removing whatever the reactive gases from inside the reactor. So we can use the gases like the neon, freon or helium to some extent to just purge that reactor. Then hydrogen embrittlement. Whatever the lattice structure is there, that lattice structure, inside this lattice structure, one lattice grain will be there. That you have to study through material science subject. In the material science core subject during the chemical engineering course, they used to define the what are the material properties. If you observe the material properties in every material, whether it be plastic, steel, iron, anything material, so it is nothing but a composed of a small molecules only. A big part of a reactor will be formed. In the reactor, if the reactor is produced using a steel or a stainless steel, whatever the carbon composition is there, it will be in the form of small grains. That is a small grains will be attached together. The boundaries of that attached grains are called a grain boundary. So in the grain boundary, a small tiny layer will be there in between two grains of iron or two grains of steel. So that hydrogen will have a tendency to attack on that grain boundary. So that grain boundary, when this grain boundary is attacked, what happens? That grain boundary will be weakened down. So suddenly that crack will come. So that crack, whenever the crack will come, that reactor will be just collapsed. So we can observe the same mechanism in our walls. When you consider our walls, that after the construction, after some time, some walls just they will have some cracks. Why the cracks will come? Because of some embrittlement. Embrittlement is nothing but just lowering its strength. So whatever the oxygen, whatever other reactive components are there, just they are entering inside, just they are entering inside and destroying that particular material. Then only a tiny crack will be observed. That if you observe that the cracks on our walls, many of its crack will be around the cement layer only. So big bricks cannot be cracked. Okay, large to a large extent, the bricks cannot be a crack. Okay, only the cement, whatever the cement in between we kept between the bricks, that crack will come around that cement only. Okay, it will not go in the brick. So similarly, so entire reactor will not be destroyed, only the grain boundaries. So it will impinge, hydrogen will be impinged into the grain boundary. That grain boundary will be just embrittled down, will just be weakened down, then that will be just collapsed, that reactor. Okay, these are the engineering problems. Okay, just confirm me, this type of explanation do you need, or I am going very deeply? Yes, Ravi, or I
No,
said,
sir.
yeah, is it okay?
Yes, sir.
Or yeah, last time also similarly I explained, but because of this research problems, the reaction engineering part I neglected, because you have not undergone the reaction engineering course. Most probably you will see the reaction engineering course in the next semester. Okay, yeah. Okay, who is number 8? Okay, number 11. Number 11. Okay, don't think that I am going to give you attendance. Okay, all the attendance sheets I have today, I just deposited to the administrative section. They will see whatever attendance you got. Okay, along with report, I am going to. I already submitted that one. Only report I have to give. Who are attending actively, who are participating actively in the discussion. Okay, today I will call this one number 11. Okay, he is absent. 27. 27. I'm not asking to raise your hand. 11. Okay, today management will take a decision regarding this one. I can remove whoever I want. Okay, whoever not responding, I will remove them from the meeting. Okay, then next one is 27. Okay, he is also absent. 29. 29. 29. Okay, 29 is also not there. I'm noting down the numbers. 29, 11. Okay, 33. 18-33, yes.
Yes, sir.
Yeah, do you have any problem? Yeah, you're facing any
No,
difficulty in
sir.
understanding any chapters, or
No, sir.
okay, I hope you're studying. Okay, study well. Okay, 34.
Yes, sir.
Yeah, do you have any problem?
Nothing, sir.
Just genuinely, just say me genuinely, whatever you're not understanding, anything until so far we covered. Since we are moving very fastly, so you can just say me. Anything I can revise from the previous one also.
Nothing, sir. కొంచెం మెల్లిగా చెప్పండి.
ఓకే, కొంచెం మెల్లిగా అంటే వాయిసా లేకపోతే స్పీడా?
సిలబస్ కొంచెం స్లోగా చెప్పండి.
ఓకే, ఓకే, యా, ఓకే. 39. 39. Okay, 39 is also absent. Okay, 49. DCT 49.
Yes, sir.
Okay. You have any difficulty in understanding?
No, sir. No, sir. No problem, sir.
You are from the previous batch, right?
Yes, sir. Yes, sir. 17th year.
17 batch. Okay. Okay, if you face any problem, I think you have not come to the earlier classes, first unit classes, maybe.
Yes, sir. I've
Yeah.
rejoined.
Okay, just watch the previous videos. If you don't understand, just let me know that one. Okay, so that I can take some extra classes to you.
Okay, sir.
Okay, you know how to go for the previous videos.
Sir, actually, those videos are saved in chats, sir. So I can't see those chats.
No, 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 no. Earlier I defined where you can find that videos. Okay, all the videos from the starting onwards you can find in this one. If you see in the teams BSc Chemical Technology, you may not get faculty one. So in the BSc Chemical Technology, our channel is there. MTO, no, not MTO one, CT2. Okay, in the MTO one also same story. CT2 CT2 channel is there. In the CT2 channel, you can find a file. You can find files. In the files itself, it is a video link is there here. If you see a video link is there here. So in this video link, one Word file is there. That Word file, when you just open this Word file, here you see one link. Just click on that link. Okay, once again, just explaining, just concentrate on this. In the channels itself, say chemical technology 2, whether it may be a chemical technology 2 or it may be a mass transfer 1, all the channels will contain one Word file. Okay, video links, which is titled as a video links. In that one, you can find a video link. Okay, control that one, or otherwise you can just copy and paste it here in your browser. Okay, paste it in your browser and it will go, it will take you to the Microsoft Streams. Okay, this is very important. Microsoft Streams, you have to use this one because when you just absent for the previous class, you can ask, you can just see, you can watch everything. If you see here, this, since that is a CT2 link, so that link when you paste it here, it will directly carry you to the CT. That will be carried to the CT2 channel. This is a channel. Okay, here if you can see what is your chapters we are going to cover. First one nuclear materials, next one natural product industry, pulp and paper, microbiology. So okay, so in this one, according to their dates, they have given. Just here in the sorting, sorted by trending is there. Na? So you just click on the by date, publication date or published date. So when you click on this one, according to their published date, you will receive this one. Okay, many videos are there from the starting onwards. I have uploaded all these videos. Okay, this is a huge task. I have done it for you. Just go and just check it. All this one. Okay, from the third July onwards, we have started a class. So along with CT2, we have covered the BSc project also in this session. So the same one I have just given here. So explanation also. Explanation means whatever the topics we are covering, I have given here. If you see nuclear fission versus fusion, nuclear fuel complex and important components of nuclear fission. And when you just go inside this one, so you come to know what are other different. So what are other different titles here involved. So you can watch directly from this video, the previous videos from here. So okay, every video is there. Okay, then if you if you can access this page, you can go to the channels. Okay, in these channels also you can encounter this one, mass transfer one. In this also I have uploaded many videos. Okay, if you see, only 5 members from our class are want, not from our class or anybody. Okay, anybody can follow this channel, whoever having this link. So only 5 members are following these links. 32 videos I have uploaded still now. Okay, only 5 members are following this channel. Okay, our class is having around 38 plus 2 or 3 have rejoined. So around 41 will be our strength. So among this 41 strength or 40 strength, only 5 members are just following this channel. Okay, I will not get any money when you subscribe or when you just follow this channel. Okay, so for your sake, I am just saying, you just follow this channel and it will be helpful to you whenever you are finding any difficulty. Just watch the previous videos and come to me if you have any doubts. So okay, here every video from the starting onwards, every video is there. Okay, 32 videos means 36. Okay, in the maximum in the 4 next classes we have to just complete the third unit. Okay, according to our schedule, but only we are in the mass transfer, only 1.5 unit has been completed still now. So you can observe how slow I am going mass transfer operation, because this mass transfer operation is derivation. So I want to use many classes of CT2 for this mass transfer, because we cannot cover in the limited time mass transfer operations. If you see in the mass transfer operations, unit 5 is very big and it is very complex, liquid extraction. So you need to understand a lot this one. So if you see, this is first video, need not to be a first video. Okay, according to date we can arrange. Okay, first you have to go to this channel. Okay, I have provided in the channels the link to these channels. So after growing, you just go to the sort by publish date. So in the publish date, you can see from the starting onwards, every video is there. So from the starting onwards, every video is there. You can watch one more time. So here, how many people already watched? 6 already rewatched this one. So here, the 4 people already rewatched this one. Then how many people like this one, we come to know. Okay, so in this way we can evaluate who are watching you, who are having doubts. Okay, we can find out how many people are just accepting whatever is going in the class, how many people can't cope up with the class. So we can just analyze ourselves, so it will be useful for our analyzing purpose. So because of this, I am just requesting you to just go to the channel, and from the starting class 30th June, I have taken the first class of mass transfer operation. So from this class onwards, you can just watch the videos for the mass transfer. Okay, the link for this channel you can find out in the respective teams channels. So here, if you see, these are all channels: chemistry 5, CT2 practical, CT2, HT heat transfer practical, industrial management, mathematical statistics, mathematics, MTO1 project. Okay, these are all there. For MTO you have to go in this one. For CT2 you have to go this one. After going here, you just go to the files. Okay, every file will be here. So for unit 1, unit 2, unit 3, unit 4, unit 5, every material I am uploading here. For the CT2 also same, I have uploaded the third unit also. Okay, third unit I have uploaded, at the same time I have given through WhatsApp also. Just you have to go here. Okay, this is the mass transfer. I have not uploaded the third unit. Second unit notes I already given you and supplied to WhatsApp also. So instead of going for the WhatsApp, it is very easy. Every material is available here. You just go to this channel and just read this one before coming to class, each and every topic. Since I am already telling you what I am going to cover in the tomorrow's class, just revise it and come once again. Then it will be useful. Textbooks, if you find anything difficulty in my explanation, you can also read textbooks also. All the textbooks I have just uploaded. Okay, if you want anything unsolved in the question papers, you can just verify the question papers from the previous whatever the question papers are there. You can let me know this problem has not been solved, just solve this problem, or otherwise try on your own. Then if you cannot solve the problem, or you cannot solve the particular type of question, just come to me, I will explain. When you go for the previous question papers only, you come to know, okay, what type of questions they are asking. Okay, I'm just teaching what is the syllabus. Okay, I'm not teaching according to answer and question and answer. but the material which is provided, the notebook which is provided to you, it has question and answer approach. Apart from this, who knows, maybe many questions I have left behind. Okay, probably you might wonder how to answer those questions. So because of that arrangement only, I am asking you to just refer the old question papers so that you can know what type of questions they are asking. Okay, DCT 49.
Yes, sir.
Yeah, is it okay? You just watch the previous videos. I just remember you.
Okay, sir.
You are not present in the first unit itself. You joined lately.
Okay, sir. I will watch the videos.
Okay. Yeah. I hope this is fine. Okay. In the next class, we will see the same unit, what you call unit 3 only. Okay, if you find any difficulty in the previous units, you just ask me where you need more explanation. Okay, otherwise if you want anything to be revised, the whole chapter needs to be revised, just say it to me. We will take one extra class, not the regular classes. Okay, in the extra class only I can revise, because I want to use the CT2 classes for the mass transfer operation, because it is growing very slow, since those are all our derivation and formulas and problems. So you just go to the previous one and just ask me what you required a more explanation, from where you required a more explanation. Okay, thank you for listening.